Okay, in this video here, we're going to look at a case study of a steel frame building grid layout, basically the structural layout. I wasn't involved with this project, but I did inherit some drawings for this from the architects, from the consultants, and it's an interesting one. And I don't know the backstory to it, but it does start to tell a story if we kind of reverse engineer it. And in that process, we learn a little bit about structural grids and columns and loading and reading drawings. So I think it's a nice one to walk our way through. So just to orientate what we have here, this is the architectural P1 plan. This is the architectural level 1 plan. This is a 3-story steel frame building with, I believe, 3 levels of parkade. So the parkade would have been all concrete, main floor is concrete, and then main floor up is all steel. So just to orientate to this a little bit, you'll see over here on the main floor plan right there, there is a ramp going down into the parkade. Okay, so what happens over here is that ramp comes down right here. Okay, so you come down on that side of those columns, and when you're leaving, you leave up on that side of those columns. And then there's a drive aisle here, and there's a drive aisle down here, and a drive aisle right there. The parking is along this wall. There's some parking along there and along there, and there's some parking along this wall like that. Okay. So now when we look at this, typically, not always, but typically when you have a grid layout, you typically have columns at the intersection of the grids. It's kind of an efficient way to lay out grids early on in design. So when I look at this, there's a couple of things that jump out at me right away. I say, well, we've got a grid line here, and there's no column there, and there's no column there, and there's been this little 3.1 grid line added there, and now the column's there and there, and there's no column there, and there's no column there, and there's no grid line for these 2 columns. So, so there's something a little bit off right there. And so when I reverse engineer as to why, here's my theory as to what might have happened here. I think originally, probably this column was there in the design drawings, and probably that column was there. Okay, and I'll just delete this grid line for now, and delete these. And probably this column was there, and probably this column was there. I would suspect that probably the design drawings had it like that. And it looks fairly efficient, seems fine. And my guess would be that there was probably parking along this wall like that as well. And the drive aisles would probably, you came down, and the intent was you come down here and you drive down here and drive down here like that. And in plan, it looks fine. Okay, because when you're laying out parking, the best way to do it is park the perimeter and work your way in, because you'll get more stalls. You don't want to put drive lanes on exterior walls or in sites on the exterior of the, against the setback. You want to put the parking first because you'll get more stalls. So that's probably the way it was, is my guess, was something like that. Now, the architectural technologists doing their job started to put together the working drawings for this. And they probably realized very quickly that, okay, with this plan, as you come down here and you work your way along here like this and like this, you're sloping down the whole way. So there's this whole thing is sloped going down, 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 because you got to get low enough at this point to get below the ramp above, to get enough headroom below that parkade ramp coming down from above. Okay, there's that parkade ramp. So it's here. So that's fine. You can slope down, 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 and adjust the slope to get until you get enough headroom. But there's a catch to that. The land use bylaw in this particular city tells you that no parking stall can have a slope of more than 4%. Oh, okay. So that means all of a sudden this drive aisle is capped at 4% because there's parking off it. Okay. And that means this drive aisle here would have been capped off at 4% because there's parking right there, and so on and so forth. Parking here, so that would have been capped off at 4% as well. So probably at some point they realized, I mean, maybe not quickly, but as they were drawing it, they would have realized at some point, I don't have enough headroom to get below that parkade ramp. So that's, that's our job to find these problems and flush them out and find solutions to them. So it looks to me like probably the solution was, well, we'll get rid of that parking. We'll move a column over here. We'll move a column over here, and we're going to move this one over there and this one over there. And now the drive lane can be like that, okay? And so they took all that parking out and they added parking here, they added parking there. And what that allowed them to do was, because there's no parking off this drive aisle, they can do more than 4%. So they just made it whatever they got to do to get enough headroom down here. Okay, so you come down at 4% here, and then it looks like it goes down to 6% for that stretch, and then 4% again down to here. Not quite as efficient from a parking standpoint, but it's probably what had to be done. And now in that process, so they moved these two columns, but they didn't move this whole grid, and they left these two columns down here where they are, and they left those two columns where they were, and they left these two and those two, and moved these two over. Okay. So that's probably my guess as to what happened there. So let's just see what that means elsewhere in this floor. And by the way, in this case here, so in the parkade, when we get to the main floor here, you'll notice if I show these side by side here, there's less columns on the main floor. Okay, so you'll notice that this whole row of columns here is gone on the main floor. And then down here, this whole row of columns is gone on the main floor. And the reason for that probably would be because, again, these columns here are supporting a concrete main floor structure. So your spans for the concrete are less than the spans for the steel. Okay. Generally speaking, I mean, working within a reasonable slab thickness, your spans are going to be not as far as steel can go. So that's probably why that's the way it is. So these columns here were required in the parkade, there and there, to break down the span across the drive aisle, but not necessarily needed in the steel portion. So they've just been deleted, and now the steel can just span the farther distance across to the outside columns. Okay, so now we'll move up to the main floor of this, and with columns, ideally you line up columns, from top all the way down to bottom. You don't want to be staggering columns, or else you get transfer beams. So if we go to the main floor, you'll see that, so we've already seen on the lower floor, they've moved these columns and they moved these columns, we think. So here they are on the main floor now. Okay. On there. Oh, and I got these in the wrong spot. That one's there, and that one's there. Okay. So again, architecturally, it's not real problematic. It's kind of interesting. There's no column there, by the way. But it would have been just as good or better to do this, right? And not have that grid line. And that would have been, a fairly efficient grid layout, basically. But we know why it's not like that. And they wanted to line up the columns. For the adjustment in the parkade, they said, well, we're going to line up those columns above as well, instead of doing a transfer beam across here, because they probably didn't have the headroom. So that's another good conversation there. So let's just go back. Let me put my columns back where they were. If this column was here on the main floor, okay, and second floor and third floor, it would come down to the main floor, and now there's no column below it, because the column below it had been moved over to there, basically. So let's do that. A column's been moved to there, and a column has been moved to there. So if you went down to the parkade, what that would mean is that column above would have been sitting right there and right there. And now it's not lying on a column. So to deal with that, you would have to do a transfer beam across here. So it's a concrete beam, basically, that transfers the loads from that column above to that column, through the beam to that column. The loads from that column through the beam to that column and to that column. So they can get quite deep. Okay, so I think if we go to we are going to look at the structural drawings, but this has a one-way slab and beam system, structural system for the main floor, and the beams I think are about 610 deep, and they're 610 deep um, without a transfer. So if it was a transfer one, you could maybe double that. Like it might be a meter deep basically. So they might not have had headroom for that. So then it's like, okay, now we got to move the steel columns up above too, because there's no room for that transfer beam. There's no headroom probably. So let's just say, okay, fine, let's move those over. And again, this probably would have been all through the process of the working drawings that all this was starting to get noticed and dealt with. So they moved the columns over to line up like that. And in this process, they didn't move that one, and they didn't move that one, and just moved the whole grid line over. And same with that one and that one, and moved the whole grid line over. Why? I don't know. Maybe by the time they realized they had an issue, maybe a lot of the drawings were done based on the original format, and now they're just trying to find the quickest way without holding up everything, basically, without re-engineering everything, and just trying to find the quickest solution to the problem. Could be, don't know. But what we do know is that they moved the steel columns, and they moved the ones they needed to, didn't move the other ones. Okay, and now we'll just zoom up to the second and third floor and take a look at this, and just so you can see again, sorry, I got these in the wrong spot again. They've moved the columns to match what we did in the parkade there. I've got that one right. Okay, so second and third floor. And it's fairly clean. I mean, it's not so bad. But let's take a look at the structural drawing and see what did this change mean structurally. Okay, let's start by looking at the main floor structural plan. So now we're looking down at the concrete slab on the main floor. And what you're seeing here is, again, I've put the column layouts in there. So, and remember, this is now above, we're seeing the columns that you're cutting through here are above the main floor. So we don't have that row, that second row in the parkade that we had here, and the second row in the parkade along here. It looks to me like in the corners here, they could have just put a column in the corner right here, and I guess got rid of that one. It looks to me like they were trying to avoid a column in the corner for whatever reason. So they've put columns away from the corner at kind of an equal distance, and cantilevered beams over top is what they've done here, and same thing on this side. So I think that's why there's an odd spot for that column, and that column is my guess. They just were avoiding a column in the corner for whatever reason. And so what we're seeing here is, so you're looking down, we're cutting through the columns. I've drawn them bigger than what they are, but this dashed line here, okay, so between there and there, there's a couple of lines, and that's B1. So what's that indicating is that there's a beam below. Okay, so it's dashed because it's below this floor. So, so from, I guess to kind of explain what you're seeing here. So from this point to this point, the slab is 250. Okay, from that point to that point, it's a B1, which is beam one. And if we went to the beam one schedule, I think it was 610 deep at that point. So that's a one-way slab and beam system. So you'll see that there's a beam running across there, there's a beam running across there, and there's a beam across there, and one across there. Okay, so one-way slab and beam system. The other thing I'm noting here is not actually, when you have a concrete wall, so the stairs here, and these stairs would have a concrete core basically, you can use the concrete as columns. They essentially replace your steel columns. So there's no steel columns there, it's just a concrete wall. Same with this as well. This was a concrete wall. They're probably being used as shear walls too, but that's why there's no column there. There's a concrete wall. So I don't think there's too much to look at on the main floor here. Maybe it's just here for reference. The other thing that I should point out here too is that where we have these beams dashed in below, oops, you'll see there's also the columns below indicated here. So there's that beam there. And if you look closely, you can see a dashed rectangle there and a dashed rectangle there. That's now the columns that that beam is sitting on. So if you go back to the parkade plan here, I don't have the structural parkade plan, but it's these ones here essentially. You're seeing them below. So that's what that structural drawing is indicating. Um, okay, so now let's take a look at one of the upper floors of steel framings. This is where it gets kind of interesting how this, the impacts of this change basically. So in green here, I've drawn in all the beams, okay? And so generally speaking, it's not always like this, but generally when you have these steel frame buildings that use open web steel joists and W flange beams, wide flange beams, the beams, you always have beams around the perimeter, okay? So exterior walls, you're always gonna have some beams. And then in the interior, the beams generally run one way. So either from left to right or bottom to top. And then the joists run the opposite direction. So in this case, the beams were running top to bottom, and the joists are running horizontally. Okay, so each one of these lines indicates the joist. You'll see 711 deep joists there. And the beams, like that's a 760 deep beam, which we can talk about later, but that's a pretty deep beam, like 760 millimeters. That's deep because that's a pretty big distance right there for a beam. And now, so let's look at this situation. So here's where our columns are now. So they lined up at the parkade, that change that was made. If we move these back over to here, where we think they might have been originally, what you would see is no beam there, no beam there, and this column would be there, and there would be one right there, and there's no beam there, and no beam there. That looks pretty efficient, okay? We just got rid of 4 beams. Not what ended up happening because of that change. We're now seeing these 4 beams added in here. Let me just finish, whoops, putting that back. So why do we have these beams? Why do we have that beam right there, and why do we have that beam there, and this one here, and this one here? Well, the reason is because this column wasn't moved, and that column wasn't moved, and that column wasn't moved, and that column wasn't moved. So you still got a beam on this grid line, but there's no column here to pick up the other end of the beam. So what that ends up doing is forcing a beam here to be a transfer beam. Okay, so the loads now are coming along this beam and this one, and there's no column. So, so what's happened here is now the loads are going to go onto this beam, and this beam is going to take the loads that way, and then they're going to take the loads that way. Okay, so it's called a transfer beam. So that's why that beam was added, because it's now a transfer beam. Okay, so now the same thing has happened on this side. So this grid line wasn't moved, like that column wasn't moved, and this one down here. So now there's still a beam here, and there's loads on this beam. Oops, on this, there's loads on this beam going this way. There's loads on this beam going this way. There's no column, so now there's a transfer beam that's taking the loads that way and that way to those columns. And same thing up here, transfer beam there. And in this case, there's a wall here, not a column. So because of that change up above, there had to be 4 beams added. So now let's just look at this. This is the same floor here, and now let's just say, well, what if we just would have reassessed where kind of everything went once this problem was discovered? So what if you just said, well, let's put, let's see, how should I do this? So now let's just look at this situation and see if there could have been any greater efficiencies done on this building if the whole grid system just would have been reconsidered. So these are the same 2 framing plans here, so that we can compare them, side by side. So the one on the left here, let's say, is that's what we ended up with. That's the reality, those 4 transfer beams right there. And now let's just move over here and make some changes to things. These arrows here, by the way, I was just studying what's happening here, but there's the columns below are actually inset more, so they've actually transferred. They've used this beam a little bit as a transfer and transferred the loads over. That's what that's all about. So what if once they realized that that column had to move and that column had to move, what if they had decided to move all of the columns. Okay, so let's just grab everything on that line and let's drag it that way. Okay, we can now get rid of that beam and we can now get rid of that beam. Okay, and now you look at that, you're like, okay, well, the grid base is pretty small in here, so why not just grab that and drag it over this way? And now we can get rid of that beam. And we can get rid of that beam and just put joists on those grid lines. We can get rid of that beam too, because there's a concrete wall there. There'd be a little beam right here, I guess, to that column, but generally speaking, you got rid of another beam. So beam number 5 just got removed. And so you can see, just looking at those two right there, the one on the right now just saved 5 beams. And so generally speaking, a beam is going to cost a lot more than a joist, because steel is usually done by weight. And if we look at some of these beams here, these are 610, so 610 deep beams. Oh, these ones are these are transfer beams for 760. So they're big. They are big. And open web steel joists have a lot less steel in them. And so it could have just been a joist on that line right there. So yeah, you could have saved 5 beams in there and replaced it with 1, 2, 3, 4 joists, concrete walls there anyways. So probably that would have been a good move. So my guess is just something prevented that from happening, at the stage of the project or something. But as you're laying out grids on buildings, I mean, this is the type of stuff you want to study. Like, what is the most efficient layout? The other thing that a person could consider in this one is, um, this span from here to here is quite large. Okay, so these are 760 deep beams, and that looks like it's a 13.5 meter span. So you don't always have the luxury in buildings like this to do really deep structures. So if you needed to get some smaller beams in there, you would just do a shorter span. So for example, this is I'm going to say 12 meters plus. You're looking at that 760 deep beam. If you change this grid bay to be around 9.5 meters, you're probably going to be able to get down to a 610 deep beam. If you change this grid bay to 7.5 meters, you're probably going to get down to a 530 deep beam. So in this case here, I mean, if I was doing this building from scratch, I probably would have seriously considered keeping, maybe I'll do it, yeah, I'll do copy this one. Keeping, that didn't work so well. I probably would have considered keeping a grid line, or this grid line here, I mean, it's still there, but I probably would have considered keeping the columns on that grid line as well. And doing something like this would have allowed smaller beams. Probably these 760s would probably, I don't know what that dimension would be. It would be a lot smaller. So they could even potentially get down to 530s. Probably that would be a 530 beam, and maybe that would be even smaller, or 4, whatever, 4 something. And if you go back in time, let me just see if I can grab all this again. And quite frankly, that column there that they've moved to get away from the corner, now you could have just used that one, right? And I'm just going to copy that up to here. You could have done the same thing on this side and get rid of that 12 or 13 meter span, but at the cost of more columns in your space, for sure. So, but that'd be something to weigh, like, is that okay to have that many columns in the space? Maybe it wasn't. They were looking for more open space, but that would be the type of thing you would assess and ask yourself. And the nice thing about that layout there, again, you get the smaller beams, but these columns, they're already there in the parkade anyways, right? So if you go down back to the parkade plan, they're already there, right there, 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 there. there, 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 and there. And so, yeah, that probably would have been a pretty efficient way to do things. Something else that could have been done here is, I suppose, this grid line here. I don't know if it does anything, but you could move it to that side like that because there's a concrete wall there as well. Um, it's probably just as equal as what it was before, but it's just something that could easily happen. If we go down to the main floor and just check things, I don't, I was kind of just browsing through it. It didn't look like it had any impact by doing this. So if we moved this column, um, if we moved this column over here, this grid line over here, that's what we did basically, is that, and that, and that, and that, and that column moved there. When I look at the plan, it's fine. It didn't land in a door or anything. Didn't land in a door. Um, didn't cause any problems there. Didn't cause any problems there. And didn't really cause any problems here any worse than what you had anyways. So, that certainly would have been a move that could have been considered as well. But anyways, it's interesting to kind of reverse engineer that and try and figure out what happened there.